right. Next up is question 8. So this question is asking for the limits of a function as it tends to a particular value. This is also again a bit of a higher level question, but it's fairly straightforward if you know how limits and some of the few formulas for limits. So let's write the question down. We know that f of x is equals to 2 and g of x is equals to 3. These both values are true when x tends to 3. So for x tending to c, f of x is equal to 2. And for x tending to c again, g of x is equal to 3. So the way to think of this limit and tending to sort of expression is that if I have a function, let's say I'm going to call it h of x, and it's equal to x plus 1. Okay, now if I know that the value of h, or x in this case, is very close to, let's say, 0.9. So for x tending to 0.999, let's say, we know that this expression h of x would tend to or be almost equal to 2. So that's how kind of the limits work. We know the final value, or at least what it's close to, and then from that we can estimate the value of the function itself. So coming back to the question, we have been asked to find what is the limit of f of x plus g of x as x tends to c. So to solve this question, we need to know one key property of limits, which is that the limits of the addition of two functions is actually the same as the limit of the two functions itself plus their sum. So what I mean by that is I can write the above expression because of this property as limit x tends to c f of x plus limit x tends to c g of x. From here the solution becomes almost very straightforward because we are already given the two limits. So we know limit f of x when x tends to c, and we know limit g of x when x tends to c as well. So from the above, and as we had noted down previously, so we can use this expression here for the f of x term, and then this expression here for the g of x term. So from that we can easily say that the left portion of this equation, the limit f of x for x tends to c, becomes 2, and then limit g of x when x tends to c becomes 3, and our final solution becomes 5. So again, the key principle which we needed to know is what limits are, why do we use them. We use them to estimate or approximate the value of a function, and then this additive property of limits. So if I have a limit of the sum of two functions, I can separate them out as the limit of the sum or limit of each function such their sums. Okay, let's look at the solution here using the sum rules for limits. So that's perfect. 2 plus 3, and then you get 5.